There is a common element between the Burj Khalifa, the iPhone, and a race car. They are at the same time complex, yet simple. Factors that are intrinsically negative led to their uniqueness. Lastly, they work remarkably well on one specific goal, but fail in many others. Okay, so sounds paradoxical, right? Well, the truth is that these three statements shape how engineers think and contribute to these projects. So let's think of a car or a building. It's helpful to deconstruct this system, meaning breaking the largest system into more manageable parts and reconstruct, putting all the pieces back together. This approach helps to identify strong and weak links, how the models work, don't work, could possibly work in terms of logic, time, sequence, and function, and how to use all this knowledge to build useful engineering outcomes. And this is one of the cores of the engineering mindset, modular thinking. And a model is just a building block that can be combined with others to form a more complex and larger system. And modular thinking is just the ability to see structures where at first there seems to be none. And our world is made of so many structures if you put your engineering glasses on. But engineers don't use this functional modular way of thinking on its own. They complement it with a broad contextual understanding of the system they are building. This can be as simple as asking if the structure is useful in the first place. George Hellmeyer, who was a former director of DARPA and played a crucial role in developing the LCD screen, created a simple checklist for verifying the usefulness of an engineering innovation. Engineers don't just build things, they have to think in clear business goals and user needs, or at least most of the times. If you are liking this video so far, please consider subscribing and liking this video. Imagine you are a part of the engineering teams who meticulously designed the F1 cars for Mercedes or McLaren. As you work, you will constantly face many limitations to your design. Available funds, resources, time, and technologies. These constraints will dictate crucial decisions, such as the car's engine power, weight distribution, speed potential, and aerodynamics. Engineers generally needs and also like to work and design with specific constraints in mind. In fact, engineers are expected to produce amazing results with all these constraints. Engineers deal in a daily basis with technical constraints, and imagine you are working in an aerospace company designing a top-notch navigation system. You will face many technical constraints, like processor speed and compatibility. Taking a look at the transistor level, if necessary, you are limited by the Moore's law that is starting to break recently. Because as we continue to miniaturize chips, we'll no doubt bump into the Heisenberg uncertainty principle, which limits precision at the quantum level, thus limiting our computational capabilities. So technical constraints will restrict the size of our processor for our navigation system. We will also find budgetary constraints such as available funds for a limited time. This will affect our choice of materials, processes, and design complexity. We will shortly encounter time constraints, such as duration of the project and specific phases and milestones to achieve. We'll also encounter regulatory constraints, such as the legal and regulatory constraints of a specific project. This can include safety regulations, environmental standards, and industry-specific guidelines. And finally, we can deal with operational constraints, such as performance expectation, reliability, maintainability, which can influence the design and development process. Adding to all these factors, and even more unpredictable constraints, is human behavior. And we have to take in account our own stupidity as designers and users and create a system that accounts for that. And even if there are no constraints in a specific project, engineers know how to create them and apply them so they can achieve their goals more easily. I think we all agree that time constraints are a good incentive to finish a project and not keeping iterating until it's perfect. Going back to the car example, when trying to improve the car performance by increasing the engine power, engineers may need to compromise on fuel efficiency. In contrast, enhancing safety features, such as adding more airbags or strengthening the vehicle structure, may result in an increase in the overall weight of the car, affecting its fuel efficiency and performance. In engineering, trade-offs are decisions that involve balancing various factors and making compromises between conflicting objectives. Engineers often find situations where optimizing for one factor means sacrificing another. The concept of trade-offs is closely related to the idea of optimization, as it involves finding the best solution that maximizes desired outcomes or minimizes undesired ones, often subject to constraints. I really like this quote from the book that inspired this video, How to Think Like an Engineer, that goes like this. If constraints are like tightrope walking, then trade-offs are the inescapable tugs of war among what's available, what is possible, what is desirable, and what the limits are. What this quote emphasizes is the unavoidable trade-offs that engineers must confront daily. Engineering teams need to compromise and optimize for what's available, what is desirable, and set the limitations. The trade-offs. From a more technical perspective, to solve many problems that arise during the project, engineers leverage many optimization algorithms such as genetic algorithms, particle swarm optimization, or simulated annealing. I was really tempted to give more complex ways engineers solve many problems and relate to everything that we talked in this video, but I ended up giving you a more high level on how engineers think about these problems and solve them, and how it would be a good way to inspire you if you are considering this line of work. And if you are an engineer, maybe this gave you a much deeper appreciation of what we do and how we solve problems. Engineering is a very cool job in every scientific field, but I think the overall perspective people have about engineering, specifically software engineering, is that it's very high paid and it has a lot of perks. And in some sense that's true, but navigating this complex and high-pressure environment is not always easy. A great example of this complexity is linear time invariant systems, and they happen to be everywhere in engineering. Don't believe me? Check out this video to learn more. See you there!